This week, we're going to learn how to develop a web API. And it's not going to be our primary focus in this course, but I'd like you to learn some basics, how to develop web API. And we're not going to get into really complicated stuff. So let's get right into it. So first of all, some really basic ideas how to develop a web application. A typical web application actually, in a very simple way to think about it, it has 3 tiers. This is probably the most popular way of thinking of how a web application is organized. And a useful web application usually has a data tier. So the data tier is where the data is persisted in a database or file storage or some kind of place where the data is going to survive the application restarts or power outage, for example. If you don't have the persistence, if you're just operating your service within memory, and of course, when the power is out or something goes wrong, the data is gone. So in a typical useful application, you always have some kind of a data tier. Now, in our simple examples, we may not have a data tier, but just to be mindful that this is very common. And then once you have data that you want to process, now this data in our IoT case, this could be the readings from the sensors. It could be the status of our electronic components, maybe LED status. So there's a various different things that we can abstract around our hardware components. Then they can be managed in a certain way, or there are maybe individual components that you want to somehow control them individually, or maybe they are packaged into a single unit. Let's say it's a robot, and then maybe you're having an object that's representing the robot. So either way, that physical object is going to generate data as time goes on. So that data will be of interest to an organization, and maybe want to perform some analytics on it, want to keep the historic events as well. So that's why a typical useful application, even in our IoT case, you will probably have the data. And as far as how the data is processed or analyzed, there's obviously many different ways to do it. I will explain a couple of ideas throughout the course, but the course obviously cannot get into too much details into these things. So we're going to look at simple scenarios. So once you have data, now this here, we're talking about one particular application. And you have data you need to process, then above that, you have the logic. This is where we say the business logic lives. And this is where we do processing. We may be synthesizing data from various different sources. We'll make decisions and evaluate, analyze, and provide useful business function. And then the top tier is, once you got all this information, this sort of useful intelligence or insights that we want to share with the world, maybe within the company or with outside applications. And then you have to present that functionality somehow. The presentation tier is about, you may present your information in the form of API. Okay, you may be presenting it in the form of um, some kind of a web interface, maybe HTML pages with some dynamic content evaluated with a JavaScript, for example. The idea of having a web application that's running on a server that actually serves static HTML pages and the JavaScripts and the CSS files or images, that kind of stuff. That style of application was very popular, maybe a decade or 2 decades ago. But nowadays, it is not very common anymore. The web applications typically will be, basically web API services. They provide APIs and then they leave the presentation tier into a separate application. That's the typical way. The separate application can be just static files. Typically with JavaScript is more popular, but of course, the API can be consumed in a mobile app, right? The mobile app on your phone that interacts with the backend API, which is provided by the web services. So that is the more typical modern application style. In the old days, the web application running on the server, they also render the static files that your browser can actually show the HTML pages and render dynamic content with the JavaScript, that kind of stuff. That has been separated out in the modern application. Just, I will say, don't go back to the old classical application anymore. This is the way it has been done in a number of years now. And of course, there's always legacy application out there. But if you're making some new application, you probably don't want to do that anymore. Okay. And a standout app architecture, a very popular architecture. Now, this is not sort of a popularized in a shorter period of time. This is actually has been building up for a long time. In the old days, we have a joint application that does everything the organization needs. And there's a lot of problems with it in terms of operations, how you maintain it, how do you upgrade it without incurring downtime to the users. There's a lot of advancements in how we operationalize the services of the software to give the maximum uptime, basically no downtime to the world. Well, of course, you have heard about downtime even with the Google services, right? And they're typically very reliable, but then that kind of downtime typically is caused by human error. But this things that you use in Gmail or Google Drive, right, for example, those things are typically very reliable. They are done in the style of what I'm talking about here. For example, there will be a form of microservices behind, lots of microservices. So here, the idea is if the application has many features, we don't put all the features in a single app giant application. Instead, we break that apart into multiple much smaller services. And we'll call it feature A, B, and C. And then that feature, of course, how do you divide up the feature? That is, use your judgment. There's going to be and that actually is not static. Even the boundary between microservices can change over time. Service A and service B may be combined at some point. Maybe service A can be split at some point later on, becomes A1, A2, right? So things can change. But the idea is a service or a microservice is implementing a feature from basically is not about implementing a layer. It's about implementing a feature, and that feature is self-contained, and it also probably has its own database. Typically, as I said, a useful service typically process some kind of data. And there's of course the silent services that doesn't process data, only basically orchestrates very different information. And yeah, that kind of style service, but most of the services will typically process some kind of data. So you have in your system, you have many, I mean, in a large application, you may have dozens of services even to actually make up your user facing application. For example, your Gmail behind the scene, I will say that probably actually would be like a dozen, at least a dozen services behind, at least. And then of course the services, this, some of them are common features that actually would be shared among many different other products. So that's kind of another advantage, is that the smaller scoped services can be reused across different products. And so a typical style is these are microservices that would be serving some kind of API. You have clients that will be talking through the API. And then the example here that shows there's a request from the browsers, from mobile applications. That is actually less common now. These things all go through API. Your microservice will serve a web API, and everything else goes through that API. That's the typical modern architecture, how the software is built. The main characteristics of microservices is that services are often processes that are running on many different servers that communicate over a network to fulfill a goal or a feature of a business using technology agnostic protocols such as HTTP. HTTP is not the only way. It's not uncommon that services will be just simply communicating over TCP. And instead of HTTP, remember that 7-layer architecture, OSI 7-layer, the HTTP is level 7 and the TCP is level 4. HTTP is built on top of TCP. And so there are cases where the performance or latency is important, that things could be built with the binary protocols on top of TCP. That can be done, but HTTP is a text-based, very user-friendly, super popular, of course. So yeah, of course, you will have a variety of different services that are going to be using different protocols. And the services are organized around business capabilities or features. So this is the key that was demonstrated in the previous image about you have service A, B, and C. They're implementing different features or capabilities of a business. And then the services can be implemented using different programming languages. So see, because you're providing an API, who cares if the service is written in Python, in Java, in C++, in whatever, right? You can use all kinds of programming languages for that particular service. And the API that is exposed, that is the specification, how you interact with the service. It doesn't really matter how the service, what language is written in. And so it can use obviously different kinds of databases, whatever that's necessary for that service. It can choose the necessary hardware and the software environment, however it needs. So you can have a lot of freedom. Once you have this microservice pattern, your microservice could be all over the map using all kinds of technologies. Then services are small in size. This small is a relative. How small is small, and that's debatable. But once you get into it, you will know what is small. So anyway, it's not a monolithic application like how things are used to be done. But the microservices are small, not tiny, but they're just small, relatively small. And they have a very defined domain they operate in. A microservice is not trying to solve every problem. It's trying to provide a particular capability. As I said, the size of that service could change over time. It is messaging enabled in the sense that it interacts with other services by exchanging messages. It is bounded by context in the sense that there's a boundary. what is owned by this service. You know, if there's some other domain and then you have to go to a different service, it has that kind of ownership. And it can be independently deployed, you know, because then you can actually have your releases and you can change services as you need individually. They're all, so in a high velocity organization like Google, they could be deploying thousands of applications, thousands of changes every day to production. And that is continuous. And then all those services can be independently deployed, and they have a very well-defined interface, and they are well tested, have automated tests, and they're decentralized. They can be released with automated. Typically, once you have so many microservices, you have to have automation, otherwise it will be chaotic. You're not just managing a single application, you're managing thousands of microservices. So you gotta have everything automated. That's when the code is checked into GitHub, for example, then your process kicks in, everything goes all the way to the production. Your change gets pushed into production, your customers will see it almost immediately, maybe a couple hours later. You know, it goes through a bunch of automated tests. It has to pass through multiple gates. Maybe there's in certain scenarios, or maybe it will have to be a manual approval, but typically all these processes are mostly 99.9% automated. All right, so this gives you a little bit of context about services and what, what do organizations actually do with when they build the software. Now, in our course, we're not getting into such complexity, of course, and when doing simple, small applications, but you have to understand the concepts. Let's take a look at an example. Okay, actually, before we talk about the example, I gotta explain something else first. Let me, Flask. Now, some of you probably already are familiar with it. Some of you maybe never used it, but either way, I'm not going to get into too much complexity here. So just want you to get basic ideas what Flask is. So Flask is a web framework. I know. Well, hold on. What's a web framework? Web framework is a collection of packages or modules that allow us to write web applications or services. And essentially, it provides the plumbing. If you build a house, it does the plumbing for you, the lower level stuff, so that you can actually focus on your business logic. You know, it manages lower level protocols, sockets, and threat management, stuff like that. So for example, we're building an API over HTTP, and then it has to communicate with HTTP. Instead of having you dealing with HTTP stuff, even with requests library in Python, right, that still can be a little bit lower level. When you build API, you have to deal with API level semantics. There are a lot of things that can be done. So there's a lot of common stuff that can be done. So a framework is saying, here's how you can do these things. And I provide you a sort of a recipe how to cook a meal. Okay. So there's a lot of popular frameworks. So here's a link that gives you some of those things. And of course, probably if you're writing Python applications for a while, you probably heard of some of those things, right? Django, Bottle, CherryPy, and Flask. Obviously, if you've written web applications, this is probably something you have already studied. So suppose you don't have any prior knowledge. If you already know, you can skip this part and then get into the example I will be demonstrating right after this. So here's a minimal applications. So simple thing is, first you create an object called app. App is convention. You call this is your your application that actually will run as a web server. And with this Flask class, and then you provide the this name is basically the module name as the, of course, this is just a convention. You don't have to do it, but why not? And then, so here, let's skip down to this. Yes, let's say we're running this as a script, and then so basically we're gonna call the run method on the app object, passing in the host parameter, which is 0.0.0.0, 0.0. This is IP address, but this is a special IP address indicates that we want the service to be bound to all the network interfaces, including the local loopback. So you can actually access the DNS application with the local host, or you can use the, let's say the host has a Ethernet port. It's provided an IP address from the router, and then that IP will be bound to this service as well. And then so you can actually access on the local network with that IP to access it, okay? So a service is always running. It doesn't stop. Of course, unless something goes wrong and they crash. Otherwise, it keeps running, waiting for request to come, and it will serve the request. So remember that request response style, that's what this is. Now, there's a one route we have defined. A route is essentially a portion of the URL. Here we're going to say is a route. So basically, if you have the IP address, let's say is localhost on a certain port, and I'll show you this right away. But here, this actually shows if you run this program, this you'll see that the port 5000 is the default port, and a service, when service is running for that, you will have a port that's open. That's how you can access different applications on a server. That's the port number for services. Okay, so this is slash, it basically is the root path in the URL, and the URL has a certain structure, right? This HTTP is this form of URL. This HTTP is the scheme, and followed by this is the basically the host or IP address, and then you have the colon, and then you have a port, and then you have the rest is the path. So here the path is simply slash. It's almost like the Linux file system, if you will, but again, it's hierarchical structure. This URL is a certain identifier to access the resources on the server. So we're gonna say, okay, slash, we're gonna serve a hello world. This will simply return a hello world string. If you run this, and then you can request the root path, and it will give you a hello world in response, okay, over HTTP. So you just have your very simple hello world application in Flask. This is a this is an example here showing in the browser that you're requesting a certain IP address and then port, then you get this hello world in response. Well, it's not flashy, but here the thing is, you could have returned an HTML page, perhaps with the JavaScript, with the CSS and stuff like that, and the images, and make it nice, just like a normal website. But as I said, this is not how applications are built today. The web applications typically will only serve APIs, and then you have static files that will be loaded into the browser that's served from a different endpoint, and then that JavaScript will be accessing the APIs. If you're talking about web application running in the browser, this is kind of how it's done today. So that route is a decorator. So in Python, we have this thing called a decorator, which is simply just a higher order function, a function that takes another function as an argument, as a parameter, okay? So this app.route is coming from this, route method comes from this Flask class, of course. Okay, so we're passing this path here. Well, there's other things we can pass in, but this is kind of the parameter here if you only have this here. So here, in this case, returning again, this is just a string. This is another one. So we may say, well, the root is going to be index page. Well, over here is not that interesting. It's just a string. Of course, you can do other things as well. As I said, HTML, whatever. Or a /hello, and another path is different from that one. And then here, this will return hello world. Okay, so now you have two routes. The decorator is indicated with this @ symbol here. This is in Python, this is a decorator, but in some other languages, you see this @ symbol also on top of a function or a method that sometimes is called annotations. That it's kind of a different thing from Python, even though they kind of have a similar flavor. Not exactly the same stuff, but it can be intuitive. This is how a function can be augmented to do other things. So the path, you can not only just have the constant path that's sort of fixed, you can also have variables in the path. This is kind of one of the hallmarks of a REST API you actually will have. For example, you identify a particular resource. If you identify a particular resource with this identifier, which may be a long, just a random string, or is in this case, you usually have a username that probably needs to be unique. Remember that REST, what makes API REST, right? How do you identify resource? You have that resource has a unique identifier. So in here, if you use this angle bracket, okay, you give it a name there, and then you can use that as a variable in this function here, and then you can do whatever you want here. By this will be taken from the path that user makes a request with, and then this variable can also you can specify a type. If you don't specify, by default it's going to be a string. If you specify int : this means this particular variable will be int type. So that's the variables in URL. So in the old days, when we were just serving the web pages from the web application, then we would render templates, things like this, right? You can have a template greeting.html, which is a template, and then you provide arguments to it, and then this template will be rendered. Like here's an example template. It has logic in it, like sort of code that will render the template, and then you have an actual response that's maybe a given greetings.html. A web page, we have variables on the page because there's a variable, dynamic content to be displayed. So this is old school, and let's not dwell on this too much. This is not how it's done today. So another thing I want to mention here is in the route, you can specify the methods. This is HTTP method. Remember the HTTP method, you have a get, put, post, patch, a bunch of other things. And those sort of HTTP verbs, they have specific meaning. If you read HTTP specification, what each of these verbs or operations is supposed to be doing. So the REST typically follows this. Is trying to use the vocabulary of HTTP to implement this API specification. So here, for example, in this case, actually, we can specify the methods of this particular route. We say you can do a get, a get and a post. And then, well, typically, actually, if we're to implement this, I would not recommend to have these two things combined together. This is not really REST here. So this is doing the HTML forms here. So the form is not the point here. We're not going to be doing forms at all. But I just want to point out that you can specify the methods so that say this REST API here, this API method is about a post, for example. Okay, what does post do? Post typically is to create a resource. In fact, it's to create or update a resource. If the resource does not exist, it will create it. If it already exists, it will update it or replace it. That's kind of what a post does. So that's about Flask. And let's actually take a look at an example. And this example, of course, we want to tie it back to IoT. This is what this course is about. And we're going to use the simple Hello World IoT project, which is a single LED. If you look at the Again, so we have this. Oh, actually, let's take a look at this circuit, right? We just have a single LED protected with a resistor, 220 ohms or 330-volt ohms. I think we have 220 ohms, and that's good enough. And then we're connecting this to the GPIO pin 18, right? The GPIO 18 pin, not the physical pin, but GPIO 18. So anyway, you can use most of those GPIO pin numbers, of course. So back to that hello world example we started out in the beginning. And here we want to build an API to control the LED to turn it on, turn it off through the API, so that you can actually expose this API to the world if you want. Well, probably not that safe. Okay, so there's other things that we need to talk about. But for our example here, we're going to have an API, a sort of a REST API here that you can make a request with, so that we can control the LED remotely. Okay, also we can even check the LED without even knowing. Let's say you don't have a camera looking at the LED. How do we know what the current status is? Is the LED on or off, right? So let's say we're going to implement this two API methods. That's what we're inserted in. So let me go through this. So the first of all, now this is Flask. Excuse me. The Flask is the same stuff. Now simply import this Flask instead of the specific classes from Flask, because I want to use multiple things from there, and I don't want to list out everything that I want to use. So we'll create the app object from the Flask class. And then we're going to also have the LED object initialize it with the pin GPIO 18. And we'll have two routes defined here. We're going to get to the route in a second. So in this main here, when we're running this program as a script, then we're going to run actually these two lines. So this is the same as before, and I have one additional thing. This is simply, you don't have to make too much out of it. This is simply saying we want to use HTTP standard at 1.1. By default is 1.0. All right. So there's no reason to go to the 1.0. So really minimum right now, it should be 1.1. That's the current most popular HTTP standard. As I explained last time, you have HTTP 2.0, even 3.0 in draft status now, but they have they have a specific use scenarios. But we don't need to do that yet. So there's two routes here. Let's say first, we want to just get the status of LED. Now, the methods, we did not specify the methods here. By default, methods will be just get. Now, get is for reading information, getting a resource. So get is for getting a resource from the server. So let's say we're going to have this, the route method is get LED, and what we're returning is now in Python, this is a dictionary. So essentially we're going to return this as a JSON, right? So you see the Python dictionary looks very much like a JSON object. It's not the same as JSON, but we want to convert that to JSON and then respond that to the requester. So we use this flask.jsonify. The JSONify function will actually turn this dictionary into a JSON string, and also will set the appropriate headers for the response. So we want to use that. And in here, we only have one field, on, and which is a Boolean value. So the LED value has a 0 or 1. 1 means on, 0 means off. And when I want to return 0 and a 1, they kind of don't have very good semantics. So instead, I want to use the Boolean values, true or false. Okay. So this is what I want to do here. And then the second route, actually, that before we look at the second route, let's take a look. Let's actually run this first. Now, Now, if you take a look at the the phone user, you see the light is not on. So I'm gonna just look at the program, not switch into that yet. So I'm gonna just say, oh, right now the light is off, right? So let's actually make a request. Now, there's I have taught you how to use the Postman, right? So actually, let's take a look at the Postman. I'm gonna introduce you a different tool also tonight. The there's a get method. So first of all, so see how do you so what I usually do is that you can create a collection. So I created a new collection called LED service, and actually we have the API methods listed here. This is a request. So when you want to add a request, just click on here, add request. So I've added this request, and also I want to use the environment. So typically I like to use the environment. And by the way, the way to switch environment is right here, top right corner. There's this drop down here. So choose the environment here. We'll have the name of the Pi as the environment. And in my environment here, actually I have just one variable right now. It's called a base URL. And the base URL, this is my host name. This will be the Pi's name, dot local, and then colon, the port is 5000. Okay, so this is the initial value. This is a base URL. We're going to use the base URL in the request. So we'll have this base URL /LED. /LED exactly matches what we have here. This is the route /LED, right? So when you do a get request, so see the request, the HTTP method here. This is the whole list of things here. Actually, not everything is HTTP here. There's something else. But the get, post, put, patch, delete, head options, these are HTTP methods. So we're going to be doing a get. So if you send this request, I have this running right now, it will respond with this JSON just as we expected, right? On is a false, right? The LED is not on. So that's what that already does. This is that we have implemented one particular API method is to get the status of LED. And then we also want to be able to turn it on and off. So we're going to call this update LED method, and we're going to use a patch HTTP. Now the patch HTTP method is intended for updating a resource. Now, of course, right now our resource LED only has a single field on, right? It could be the case that we have other things about LED too. Maybe we're gonna give a unique ID. Maybe we have a name. Maybe you have a location where this is located, right? There's other things you can attach to it, of course. But so that's why I want to use a patch, because I only want to change one thing, is to turn this on and off. So the on field is what we're trying to update. So I want to use patch. And the way to do it here is first, when you send the patch, we have to specify, do you want to turn it on or turn it off? How do you provide that information? So we have to send a request body. The request body is also a JSON format. So the JSON format, we're going to also use the same JSON like as we receive a response. So we're going to pass in like on, right, a JSON object with on field, which is a true or false. If it's a true, we're going to turn it on. If it's a false, we're going to turn it off. So we're going to get that JSON from the body, the request body. We're going to use this get JSON using the request object from Flask. And then we're going to get this JSON object. And then this is actually becomes a dictionary. Okay. So we're going to see if this actually, the JSON contains, the request body contains this on field or not. This is what the request sends in. So if it does have it, and then we're going to read this value, right? This value will be true or false. We're going to convert that back to 1 or 0, because that's the value we're going to set on the LED, because this is the GPIO 0 library wants us to do. It wants a 1 or 0, right? So we're going to have to do that little conversion here between the semantic, what want to interface with the user, the API, want to expose to the world, say true or false. But internally with the GPIO 0, it needs to take 1, 0, and 1. That's why you see this conversion here. Here we have we're converting the 0, 1 with a boolean to a boolean. Here we're converting that boolean back to an integer. All right. Okay. So then if this is done, this basically will turn it on or off depending on what we're passing in, right? And then if it's successful, we need to return a 200. 200 is a status code. That's the HTTP standard. In the response, there's a status code. Is 200 means okay, it's successful. So this code is important for the API consumer to know if some operation is successful or not. If it failed, in this case, let's say you did not provide the on field in your request. If that's missing, because that's required here, if that's missing, then well, we're gonna give you a 400. It's actually a invalid request. Okay, maybe you give some more meaningful information here to say, well, you're missing on field, right? So of course you can do a lot of things over here. So we're not only gonna make a JSON response body, also we're gonna provide a status code 400 to indicate an error. So we're gonna use this make response function to do that, which takes these 2 arguments, all right? This is the body and this is the status code. So that's that. This is the update LED API method. Now we're gonna also use the postman to do that. So we see I created another request. So in postman terminology, it's called a request. So this is another API method. I call this update LED. So the URL is the same thing, right? /LED, right? This is the URL. And then the method, HTTP method is a patch. So you specify patch right here, you choose from this dropdown. And then you want to provide a body. So here, so you're going to click on this body right here. We're going to actually give a JSON body. So how do you even get to that point? So by default, this is not even available. So there's if it says like a none, what you do is you select raw, and then it will show up there's a drop down right here shows up, and you can choose the type of data. So here we actually is JSON, okay? And then you can write out your JSON like this, you know. So this is our request body. If you send that, we're gonna get a response. So what's the response? Well, remember in our response, if it's successful, we actually did not provide a body. There's nothing to say except to give a status code 200 say successful. Okay, there's nothing else to tell you. It's done, right? So this the status is 200. 200, the status message says okay. 200 means okay, and it has an explanation right here. Okay, and there's actually no body. If you look at the header in the response, you'll see the content length is 0. That means there's no body here. We don't need to provide a body. All right. So that is that. Now, of course, it was actually off. Now we turn this off. Yeah, it doesn't really do anything. Now how do we turn this on? To turn this on, you're gonna send this, say, I want to turn this on. On is true in our request body. So, pay attention to this phone user image here. That you should be able to see. If I click on send, the light is on, right? Now, if you cannot see clearly, just stop the share and I will see this light is on. And let me go back to sharing. And then of course, now it's on, we can turn this off again, right? So say this is false, we send this request. Now that light is turned off, correct? All right, so this is our simple application, and this will give you a little framework how you're gonna even make more complicated stuff here. All right, so this is a API. This API runs on the Pi, okay, and it needs to run on the Pi because it needs to connect with the GPIO devices. So we have LED we need to interact with. So to run this, by the way, I did not show you, but you just have to, let's say I cancel this, and you just click on this run button right here, run, okay? And by default, see, this is the VS Code is very, very useful. You already exposed that port 5000. That's already forwarded. You can already just, access the as is. So basically, if I open a terminal, by the way, you can use a terminal right here. In the VS Code, I did not show you before, you can actually click on this. It will split terminal, and you add a new terminal right here to the right-hand side. Okay, kind of small space, but you can actually make do with having another little terminal, so you can see what's going on right here side by side. So now I've shown you Postman method. There's another tool I'd like to introduce you. That's the terminal-based. It's very convenient if you develop APIs. This is the fastest. The GUI is nice, and this is kind of what typically testing engineers would want to use this for automation and stuff. And this is a sort of for non-programmer type of a usage. And but this is also convenient. Gives you is a nice interface. So let's say we don't want to use Postman. I want to introduce you a new tool. The tool is called HTTP. Now, so first of all, let's kind of just search this, Google it, HTTP. Okay, so you're going to go to their website. You can read up about this thing. Now, the way to install it, so you just click on this install, you'll see there's a read more. And then in the case of, we're going to install this on Windows, right? So if you use Windows, essentially you can just use a Python to install the HTTP. You don't need to follow these two lines, by the way. All you need to do is essentially just do Python -m pip install. -m means the module, it runs the pip module, and then use the install command from pip to install HTTP. This dash upgrade is not necessary if you don't have it. If for very first time is unnecessary, but if you have it already, then you will upgrade it this way. So just install, just the Python pip install HTTP. Just single P here, not double P. HTTP IE HTTP. All right. So this is a wonderful tool. I would say if you are familiar with the curl on Linux, this is better than curl. I would say curl is a classic. It's been there for ages. It's default. It's a part of Linux. Well, not necessarily part of it, but for most Linux distribution, you're gonna have it. But the HTTP is modern, is very user-friendly. Okay, so it's intuitive too. So I would highly recommend that for you. Now let me show you a couple of things here. So let's test out our API. So instead of going to our Postman, so I'm just, while you're developing stuff, and this is the quickest way. So once you got that installed, there's one more thing that I want to actually point out is that, so when you install the HTTP, it's going to actually show you a message about it's going to actually add HTTP into a script location. So I don't have a screen to show you, but when you do install, this thing, actually it will show you, and this doesn't have something to show up here. So when you install this on Windows, okay, this is a Windows specific. On Windows, it's going to show you that the HTTP is going to give you actually a binary you can run. The command is HTTP. That HTTP command will not be executable unless you put the path wherever this is located, the installed tool HTTP, that executable needs to be put into your path. Okay, so the way to put onto your path is, I hope you kind of already know how to put something into the environment to add a. I'll do a separate video to how to show you that part, by the way. So for now, let's assume you got it installed. You have the HTTP command. All right. So what you do is simply run HTTP. Now, the place I'm demonstrating. So this is actually. Oh, never mind. We cannot demonstrate it here. This is actually on the Pi. We don't have this installed there. Now, we can install it there too. So by the way, let me just install it on the Pi too. But the point is you can run this outside the Pi. Actually, it's better to not demonstrate it on the Pi because kind of just want to show you, that's the whole point. You have this service running on the Pi and you should be able to access this API from other places, from other computers on the network. Then if you know how to change your router setting, you can actually expose this to the internet if you want. Now, just be careful about security. For just simple experimentation, you can do it. But if you're interested in wanting to know how to do it, and maybe I'll give you some pointers there. But this is typically not how companies run applications. Obviously, there's a whole lot of security concerns that you have to take care of. So anyway, so the way to do this, right, is essentially there's a bunch of shortcuts. So anyway, so you're gonna just say RP. This is my host name, okay, and then the port 5000 as the default, and LED. This will by default do the get. If you actually want to specify get, HTTP get. This is what you do here. Now, if you don't say the get is implied, okay? Just like our API route in the program. And when you run this, I need to provide the full .local. So see, the thing is about a local hosts, the way to access them, actually, ideally, you should always have the .local here. Sometimes without .local may work, but it's not very reliable. So use .local instead, the hostname .local. So now you see the response, this is the response. And we get into 100 okay, and then there's a body, and the body is the JSON on is false. So the LED right now, of course, is off, right? So now let's actually test the other API in the patch, right? So we want to update the LED status. So that's what we're going to do here. So this is the path. This is the URL. And then you wonder, why are you not specifying http://? You can, but that's, again, default. And I want to save some typing, okay? All right. And then we want to give a request body. Remember what we did in Postman? We need one good request body that has one field on. And so with HTTP, it's simple to do. And it'll say this field, we're going to say on : equal, let's say true. Okay, this is going to create actually a JSON body. Now, if you want to see the request body, I do a -v here. This is the option for HTTP, and -v is the verbose mode, and then we'll give you the full request, and then we'll give you the response. Okay, so we'll see what we actually sent. So this -v will allow us to see. You don't need a -v for this to work. -v essentially, I want to show you what the request looks like. So that's the request right here. The first part is the request. You see the headers. We're doing a patch /LED. This is the HTTP protocol. And then over here, we have a request body. This is the JSON that we wanted, just the same how we did in the Postman, correct? So this is, of course, LED is lit up right there. And then the response is 200 okay. There's no body. Content length 0. There's no body here. All right. So that's it. You see the request and response, right? This is exactly how HTTP works. If you are HTTP protocol, is that, remember what I show you, that line, that's how they're done. This essentially shows just like how HTTP is done. You have the header line, but you have the line of the HTTP method, path, the protocol version, and then you have a bunch of headers, and then you may have optionally a body. The response is similar, okay? But you have the protocol, you have the status code, status message, and a bunch of headers. You may also have a body. So this is HTTP request, response, request, response. okay? And then let's take a look at the status again now. This says now on is true, right? Now, this is showing you the HTTP tool, and I would recommend you to use this. And then this is going to be very useful for API testing, and this is the more direct, convenient. You don't have to deal with doing a bunch of things in the GUI and the Postman. Is actually much more slower. This is the fastest way, if you will. So I wanted to just kind of learn a couple of basic commands. There's a lot more to it. You're welcome to read the website and then just try out different things. And if you have questions, let me know. All right. That's what I want to show you in this video. I'll record another one just to show you the HTTP installation, about adding the thing to the environment variable on the path. Okay.